So in the last class we have studied about curvature, and we have also seen what is the formula for curvature for Cartesian curves, right? What was the formula? The radius of curvature, it was given by 1 plus dy by dx whole square raised to power 3 by 2 divided by d2y by dx2. So the modulus of this quantity. This was the formula for Cartesian curves. So what about this parametric curves? So for the parametric curves, we have the equations are represented in terms of some another variable. So this time it is t. All of you please mute yourself. Yes, thank you. So we have the parametric equations. They are the equations represented in x and y, where both this x and y, they are some function of t, and this is some another function of t. So it is represented in third variable, which is t, right? So these are the parametric curves. It could be t, it could be theta. So here in this case, what would be dy by dx as in the previous case? So it is calculated using this formula dy by dt divided by dx by dt, where what is this quantity? The derivative of the curve y with respect to t. So the derivative of this curve with respect to t, it is given by the derivative of g of t. So g dash of t, and the derivative of x with respect to t. So that means we have to take the derivative of this term. So that means f dash of t. So provided this derivative will exist whenever it is not infinity. At which points it will be infinity? Whenever your f dash t is equal to 0. So we do not want this point. That means it should not be equal to 0 at any point. This is the condition. Similarly, the second derivative is calculated by differentiating this first derivative. So I have substituted its value. So you can differentiate it applying this quotient rule. So this would be there. And then once you have the first derivative, the second derivative, you can substitute all these quantities in this radius of curvature term. So this is the formula for radius of curvature. So I have just substituted the values and simplified. So this is your final result. So this formula you should remember. Yes
मैम इधर तो कुछ दिख नहीं रहा मैम.
So we have discussed about this parametric equations. We have, if the equations are of this form, x is equal to f of t and y is equal to g of t, then the first derivative is given using this formula, and the second derivative is calculated using this formula. So we can substitute the values of first derivative and second derivative into this formula, right? So we would have this final formula for parametric curves. So using this formula, you could calculate this radius of curvature for parametric curves. This formula you should remember in order to calculate the curvature for different curves. So let us have a look at one question. So in this question, we are to calculate the radius of curvature for the curve where x is defined in terms of some function of t and y is also defined as some function of t, right? So firstly, what we have to do in this is the formula. This formula you should remember. So in this formula we have the first derivative of f, the first derivative of g, the second derivative of g, and the second derivative of f. So all this quantity we should know. We already know what is x. X is f of t, which is given to be this curve, and we also know what is y. This is given to us. So now let us differentiate this curve with respect to t. Now why t? Because our independent variable here is t. This is a function of t. So we will differentiate it with respect to t. So once you differentiate it, you have f dash t. This is equivalent to a as such, being a constant. The derivative of cos t is minus sin t, and then the derivative of this term would be on the application of product rule. Firstly, the derivative of first term, that is 1, second term as such, then first term as such, the derivative of the sine t, that is cos t. Similarly, we can double differentiate it, a as such, this sine and sine terms cancel, so we are only left with this term. So here the derivative of first term, second term as such, then first term as such, the derivative of cos t would be minus sine t. So this is f double dash t, this is f dash t, and then similarly you could calculate what is g dash t and g double dash t. So these are, once you have all these values, you can substitute these values onto here in this formula. So let's see, what do we have? We have f dash t, that is only a t cos t. So its square would be a square t square cos square t, and then g dash t. G dash t is again a into t sine t. So when you square this, you would have a square t square sine square t. So a square t square sine square t whole raised to power 3 by 2. And then here again f dash t is this term, g dash t is this term, then f double dash t is this term, and g double dash t is this term. So you can put all these quantities and you can simplify this. So here you can take a square t square common, so you'll be left with cos square t plus sine square t, which is equal to 1. So this becomes a square t square whole raised to power 3 by 2. And then we have, when you multiply this, and you can take a square t common out of all the terms, so you will be left with these terms. So from here you see, if you take t common from these two terms, you will be left with cos square t plus sine square t, which is again 1. So this is t, and this term and this term cancels with each other, so you are only left with a t. So what is this? This is your radius of curvature for parametric curves. So this is the very simplest of the formula which you can have to solve these kind of questions. So this is one question that you can try by yourself. It says, find the point on the curve. The curve is given to be x is equal to at square and y is equal to 2at, where the radius of curvature is equal to latus rectum. So now here they are asking what is the point such that your radius of curvature, this rho, that is equal to the latus rectum. So what is the latus rectum for this particular curve? This particular curve is the parametric equation of parabola, whose latus rectum is 4a. So this won't be given in question. So you have to know what is the latus rectum of a given parabola. So this is given to be 4a. So firstly, what will you do? You will first calculate what is the radius of curvature for this particular curve. Then you will substitute it equal to 4a. Then whatever is the values of x and y, that would be your answer. Right, so that would be the given point. So this question you have to try by yourself. So this is the curvature for parametric curves. So if anyone is having any doubt, you can ask.